Hey everyone, it's Brad from RoboFlow, and I'm excited to be here to share some results of an experiment that I ran around transfer learning and how the similarity of your starting checkpoint affects the final quality of your model. So what I did was I took a task, which for this I used a mask, no mask data set where I was just trying to detect whether a face is wearing a mask or not. And what I wanted to determine was how it would compare to train a model from scratch just on the images in my data set versus how it would perform if I did the traditional thing of using the COCO data set of common objects, which includes things like people, but also things like fire hydrants and giraffes, and use that as the starting point for my model to learn from, and then added on my mask, no mask images from that checkpoint to train, and compare it with something that was a lot more similar to the final output, which is the wider face data set. So that data set is a bit smaller than Coco, but it's mostly composed of faces. And so the experiment that I wanted to run was, is it more beneficial to start from a data set that is full of faces if I'm going to be looking at faces or specific types of faces, I guess, masks versus no masks? Or is it more important to have a really wide variety of photos like in the Coco data set to start with, even though they're not as similar? So what I did was I used RoboFlow Train actually to do all of these tests so that we could hold everything constant, including the data set, the model itself, and all of the hardware and infrastructure and code around it. So the only thing that we were changing between these tests was the starting checkpoint. And again, that was a uninitialized random starting point, the COCO data set, and the wider face data set. I also threw in the BCCD data set as a starting checkpoint as kind of a perverse case. So this data set is of microscope slides looking at white and red blood cells. And my hypothesis was that this should, at the very best, be similar to starting from random weights, but I expected it to teach the model things that it would be hard for it to unlearn. And so I wanted to see actually if that was true, if it was possible that you could pick starting weights so bad that it was better, that it was worse than if you started from scratch. And so here are my results. It turned out that starting from Coco, let's start from scratch. So starting from scratch, I got a 77% map. When I started from Coco instead, it turns out that there was stuff to generalize from that data set. So the intuition behind transfer learning is that there's a lot of things about photos that your model can learn from other data sets. So think about things like textures and curves and straight lines and zigzags, sharp corners. All of those things are present in a wide variety of photos. And so if you can bootstrap your model with knowledge of those basic image primitives, it should hopefully be able to learn better about things in your data set. It gives it kind of a head start. So with the COCO data set, that actually panned out. We got an 83.6% map. So that was actually much, much better than starting from scratch. But it turns out that the wider face data set, even though it's a lot smaller, it's only got 16,000 images compared to over 200,000 in COCO, it gave me another boost and got me all the way up to 87.5% map. The precision boosted as well. The recall didn't quite get there, but that's probably within the realm of statistical error. I was really happy with this map increase. And interestingly, that BCCD data set of the microscope slides, it turns out that it was actually a little bit worse than random weights. So what this tells me is it's more important to start from transfer learning weights from a starting checkpoint that is very similar to your data set than it is to find one that has a ton more images. And also that it's possible to choose a starting checkpoint so bad that it's worse than starting from scratch with randomly initialized weights. So I feel like I reinforced some of my intuition. I learned a little bit of new things from this experiment, and I hope that you did too. If you want to see more experiments along these lines, please leave your ideas in the comments. RoboFlow Train makes it really easy for us to stand up these kind of head-to-head tests